Hello and welcome back to the Innovation Room. My name is Daniel Guajardo, and today I'm joined by my co-host Derek Tobolski. We got a pretty good show here for you today. We are actually going to be talking to Rider Adkins, who is our senior software developer at North American Signs. So switching things up a little bit, get somebody from the internal team here on the show just to kind of talk a little bit about what they do, and with the topic today being IoT, the Internet of Things. We think he's a really good person to speak on this subject. So let's, without further ado, jump right into it. IoT, the Internet of Things, talked about quite a bit in the technology world, but not so much in other industries, especially ours. We believe it should be talked about more. So, Ryder, how about you tell the people what is IoT?
So the Internet of Things is basically a bunch of little devices or little machines just talking to each other, and there's very little human interaction involved. And basically what they do is just transmit data.
So, I guess, can you give an example of a device or something we might use in our daily lives, kind of utilizes the technology?
So some of the most common devices out there are maybe like smartwatches that can track your heart rate or it can track your blood pressure. You could also have, say, a Ring doorbell that has a camera on it and it will notify you if somebody is approaching your house. These cameras could also be inside. It could just be for your own general security of what you want.
Okay, so the IoT in that situation would be your doorbell transferring pieces of data or information to your smartphone, smartwatch, or whatever your device may be, and then relaying that information to you so you understand what's happening.
Exactly.
Okay, well, that makes a lot of sense.
The problem here is just IoT by itself. It's just so broad because you have like the consumer side, which is like, your smartwatches, your home security, but you also have like tiny embedded devices. And I guess it's like, how far do we want to go?
And then, Ryder, how do you guys use it in your guys' world? I mean, I know there's probably a million little things that, like you said, so many sensors and little data systems talking to each other that, essentially everything then all gets put into a cloud somewhere, information gets processed, and then it gets sent back out. But how do you guys, in your everyday, Ryder, how do you use it? How does it change your world? I mean, it's got to be ever changing for you guys.
Well, it definitely is ever changing. That's something just as IoT as a whole, things change every day. There's no best way of doing something, and maybe you decide to do something one day one way, but then next week there's just a completely better way of doing that thing, or there's potentially something wrong in the way that you did it. So at least on kind of like the cloud side or the data processing side, all pieces of data just gets pumped to, say, like some server somewhere, and we process that and kind of like can send out notifications to people that are interested. So as you guys were saying earlier, say a piece of equipment is starting to die, or maybe it's time to service it, or maybe there's like something wrong in the LEDs. Maybe some LEDs are going out. It's just like a simple notification that could be sent out to somebody either through like an app on your smartphone. It could be sent through email. It's just letting someone know like, hey, this thing is happening. And that prevents, say, an actual person discovering it on their own and letting someone know that there's something wrong. So IoT is like this, it's like this idea of all this, like you have a lot of data, you need to process it, and you need to just send it out somewhere else, somehow, some way. It could either be like human readable form, such as like an email or an app notification, or it could just be sending that data further to somebody else and they handle it.
Yeah, so I see it. Like I see it a lot in my home. Like I understand it. I've kind of taken that next step in my own. Like I don't know it from your world, but I know it from my own world of my home. I've got my thermostat. That's a smart thermostat. I mean, I don't know anybody that there's not a whole lot of people that do. If they get a new one anymore, it's usually a smart one. We got some smart switches in the house, some smart outlets, even my sprinkler system outside, like it's all Wi-Fi based now. And I've taken the next step into what started as a little Echo Dot, that little Amazon Dot thing. We started with that, and we didn't really know how to connect all this stuff. And now, like, we've gone to the next step. We've gotten that bigger, like, Echo Home or Show, whatever they call it. And it's to the point now where all of those apps who used to work singularly in my smartphone now all get connected into the Alexa app. And not only can you control it all from one app, now you can actually, like, you know, and this has been around for a while. I say now because it's new to me, but now I can just tell it to do something out loud, and it does it. It changes the channel on my TV, shuts lights off, shuts TVs off. You can put it on time schedules. And, you know, even like my thermostats, it's learning what I do when we're here, when we're not. And I know when I think about that, I think it's like crazy. And I start I connect the dots then to how we work with you internally within our company. You know, and we come up with an idea and it's hey, can we make our system over here talk to our system over here and send us weekly emails for reports that are this, and then get data analysis that, you know, get sent over to us this way. And you guys then go behind the scenes and kind of make all that happen. You connect all those dots. It's almost like you make all the different systems and portals talk to each other. I mean, to me, it seems like a crazy world. Is it as crazy as it seems, or have they gotten it to where it's not hard to get all those things to talk to each other?
Right at the start, it is crazy, definitely, because everything is just kind of sporadic in a way, and you have to figure out where everything is and kind of bring all of these pieces together in a way and kind of build something on top of it so that everything else interacts. So say either different devices in your home, they were once all separate, as you were saying, but now you can have a smartphone app or an actual physical device in your home that you can talk to that will then send those communications out. So when you once had maybe 3 or 4 applications that all did their own specific thing, either mess with the thermostat or mess with, say, the Ring doorbell, now you can have one app that kind of just says, all right, well, I want to do these specific things, and here are the devices, here's how they're connected, here are the common commands, and everything is just linked up that way. But it is definitely hectic, but eventually it all kind of just comes together in a way.
Now, when they set these things up now, or when the code's written for, I would assume it's code that's written for all these different apps and systems of that nature, do they have to be set up in a way, and are they like intentionally set up in a way to where there's the ability to get them to talk to other apps or systems or programs? Because I think of this thing as like a giant, you know, the old phone switchboard.
Mm-hmm.
Where, like, I think of it as a giant, you know, switchboard that you're just hooking all these different things up to. Do they set them up that way? I mean, is it all code based that allows it an open platform for it to talk to something? Is there something you have to do straight out the gate to allow that access, or is it just something you can add later on?
It's something you could add later on, and it all depends on kind of the devices you have and like the companies that you buy them from. So if you go with, say, like a startup company that just introduced a brand new device, they may just have that device working as is with their own application, and they just wanted to get something out the door for consumers. But then they could decide later on, well, maybe we want to integrate with Alexa on Amazon's platform. Then they could basically kind of create those sort of communication channels in a way so that you could hook it up to your Alexa device, or you could hook it up to your Google Home device. Like any of these other devices, like the companies will kind of create these contracts in a way to be able to talk to either the devices themselves, or talk to, say, the server that kind of talks to the device for you. So there's a couple different ways that it could happen. And I would argue that if you're talking directly to the device itself, there could be some security implications there that maybe the device itself isn't secure. So as far as consumers knowing that, we're too early in the stage of IoT to kind of like educate everyone on if it's safe to really bring all these devices sort of to life and allow them to interact with any other, say, like platforms such as Alexa or Google or any device that you want to, interact with.
Because they're very much AI devices at that point in time, right? I mean, within certain constraints, but they're AI devices.
I wouldn't say AI devices. It's more they serve kind of like one purpose or a couple different purposes. They could be learning, that's the thing, but as far as these devices learning on their own, they're not at that stage yet. It's more that, say, a company's server is kind of like learning for you. And that's just based on all the data that it receives and it transmits.
Yeah,
So,
the data sets have to be received first before it can start providing suggestions or giving you examples of what you need to do. So going back to like how these can be implemented or people are starting to use them within businesses, inventory management is a way that IoT is being used, being able to record every single time a part is used. If you're, say you manufacture with raw materials and these raw materials are set in a certain bin that has a tracker on it, maybe by weight, maybe by a slot that this part sits in, and when a part's removed, that's automatically tracked. So you can have your inventory orders automatically set up or ordered for you. After it learns so many things about your inventory, it could even start suggesting other materials that you could probably use instead of the materials you're using. It could let you know that maybe you're not using so much of one material in a year or 3 years, but all that data still needs to be recorded first before it starts really giving you those suggestions.
Yeah, definitely. And the thing to understand with everything that you just said is it's all going to be like company specific. There's no like sort of like out of box solution that you can just like plug into your company or even plug into your home if you wanted to kind of like track certain things that go on in your home. It's going to be specific to your company that it kind of detects your behaviors and it knows your inventory and it knows kind of like your sort of work process either in the manufacturing sense or in the project management sense.
Could this be industry specific at some point though? I know these are all very specific to companies, but almost as like a benchmarking tool, you can see where all the other companies in your industry kind of fall, and maybe some out of box kind of thing could be made for your industry. But I don't know if that would be possible because it might still have to adjust based on your use.
It could very well kind of serve as like an industry standard, but to get other companies that say have been in the field for a while to adjust to this sort of standard to kind of like benchmark how they're doing, I think that would just be more work involved than it like that you would benefit from, I should say. It's more for, say, newer industries or industries that haven't even been created yet. You could potentially have like these benchmarking things in place, but that sort of requires that every single company adheres to these standards, which could stifle innovation or it could not.
I know we've talked about industry specific, right? I know you and I have talked about, even our own facility and how kind of we do things not only on a project management side, but manufacturing. Dan and you kind of hit on inventory, and how that could help not only project what you need, but also give you the data analysis of what you've used. You've talked about before, I think it was having iPads as scanners as a sort to check in and out or take inventory from specific areas, almost, and I think it was another individual that was talking to us as well, almost like a vending machine type thing. How does that all work? How does that all connect? I mean, I know we're talking about it, but like, it's got to be a giant database at that point in time, right?
Well, when you're talking about one company in particular, it's not going to be a giant database. It's essentially going to be a database that, say, holds your inventory, if that's what you care about. And you're going to have devices or say iPads or something like that that just say talk to your servers in a way that says, all right, well, this person pulled this inventory or this person returned this piece of material to inventory. So it's all tracked in like one database. And when you're talking about sort of like basically numbers on or quantities of inventory, that's not going to be like the biggest thing to sort of worry about. You could essentially run that on a little tiny device that is smaller than, our smartphones that we use today and less powerful. Now, if you want to derive sort of analytics from it, you're going to need a sort of like a beefier computer to kind of handle all of that. But it's basically you have a server, you have these devices that somehow directly or indirectly talk to that server, so transmit that data to the server, and the server can kind of handle that however it needs to, either updated quantities or sort of deriving some reports or even sending those notifications that we talked about earlier.
So that could eventually talk, like our systems then could talk to the other systems that we order our things from, correct? Like we could end up hooking this up to our other inventories with who we buy our product from, and it could let them know when we're becoming short on product. And really it could end up getting to a point where it ends up ordering product for you or giving a suggestion to where all you have to hit really is okay, right?
No, exactly right. Exactly right. If you have common material that you use, say lumber or sheets of metal, and say the system can detect, all right, the inventory quantity is getting low, you could start off with kind of like supplying those parameters to say, well, if it gets to this quantity or below, we could kind of do, as you said, where we can suggest like, well, maybe you should order more of this. We could kind of, again, start with like a quantity. Say we suggest that you order X amount of quantity for lumber because we just reached that threshold. And people kind of participate with the system and they say yes or no, or they manually adjust it and say, all right, we don't need that much lumber or we need more. And what could happen is these systems sort of learn from our behavior. It's like, all right, well, we always undershoot what we kind of suggest. Let's kind of tweak that a little bit in the background. So then once somebody receives like this notification, like, hey, we're low on lumber, we should probably order more. Here's the suggested quantity. People will just say, okay, yes, order it. And it will just order from, say, vendors that we have specified as far as lumber goes.
The biggest benefit of this is that it really dials things in and it works in real time and adjusts. So say like it tracks that you've used 6% increase in a certain type of material. It can then recalculate and estimate a new order date when you need to order that material. Or if you have something that's gone up by like 50%, Amazon uses a lot of this stuff, and that's how they're always able to restock everything so quickly, get it shipped out so quickly. And then they've even gone to the point to where they're using automation to pull this inventory and load it onto trucks or load it into an area where then a person will put it on a truck, but they're using flight patterns to do this. So these robots are constantly moving around these large warehouses, and everything is just communicating through IoT to one another and alleviating the need for, what would probably be a 100 to 200 person workforce per warehouse could be maybe like 20 people or something.
No, exactly right. And what could happen in the Amazon scenario, they could basically look at the live feed of what's in people's carts before they order. And they could see, well, this person generally orders everything in their cart after an hour or so, and these people don't, and they could adjust their inventory from that and expect it right then and there, rather than once they submit the order.
That is a huge advantage that a human could not even do.
And as far as in, say, a manufacturing sense where you're pulling inventory, it could be the same exact thing where inventory is pulled and we kind of react from that right in that instant. And that's where the IoT aspect comes in, because you need those devices to say, well, this inventory got pulled, rather than relying on, say, a human to say, we pulled this inventory, because there could be mistakes there. Maybe they pulled the wrong inventory, or maybe they entered the wrong inventory. With IoT, it's kind of like you have this sort of guarantee in some aspect of what inventory was pulled and what quantity, and that's an immediate reaction rather than delayed.
Yeah, it saves tons of money too. If you save like 5 minutes a day on 30 different tasks across your entire organization, add that cost up over a year, the savings just start to really pile up when it comes to anything augmented or automated.
So go ahead.
Or even like partial automation, as Derek was mentioning, where it's kind of like we implement the ordering system in there where it kind of is sort of reactive, where, all right, well, we're running low on lumber. We get the notification, so let's start ordering more. So even that time saving, rather than somebody looking into, say, some reports and seeing what inventory we have left, instead of being like reactive in that part, it's like retroactive, because you get that data right away. You get those notifications right away, and people can just decide right then and there to actually order more inventory.
It could also price match too across all vendors. So say it's an item you order maybe every 6 months. Market changes, obviously, as we saw last year with raw materials, they kind of jumped to record highs in certain areas and within weeks. But when it knows that you need to order, typically a person will go to the same vendor they always use, maybe the same 2 or 3 vendors they always use. But this can really just benchmark, I guess, or test what the price of that current material should be across the market and see if maybe there's a vendor that has it at a cheaper cost. And to reorder another 6-month supply, that could save you quite a bit of money as well.
Okay, so I'm curious, and I have to ask, just because it's always a thing you hear about it with the home devices, let alone with like, implementing in a business. You hear about, hackers that can get in and see in the video, they can grab a hold of the cameras and talk to the devices and things like that. Like when I think about ordering stuff from businesses now, I'm thinking about, okay, what kind of hackers could get in and could they potentially, wreak havoc inside of their, being able to order and talk to other systems like that. How secure are these devices right now? And when they talk to each other, is it easy to hack? Is it something that I'm assuming it's something they're constantly working at, but what do you know about that?
I would say for consumer devices, they are generally easy to hack. As you just mentioned, like we have people now where their Nest cameras in their house have been effectively hacked. People are talking through the microphones and they could see the video feed. As far as that security goes, yes, it's extremely vulnerable, and my personal thought is that's just the nature of IoT as it stands today, because IoT is still a relatively new concept as far as implementation goes and the actual devices. We're still early. We are extremely early to this field, and we're still learning sort of what companies we decide to trust. We're still learning what devices we want to use. And I think at the end of the day, what's going to happen is we as consumers are going to decide what devices we like, what companies we like, as far as, data leaks from that company, from these devices, or just the devices themselves in terms of sustainability and how long we can actually use them before we have to go buy a new one.
So a lot of our computers have software updates, things like that have built-in kind of protection, but then they also use like an outside platform to help protect your computers against viruses, things of that nature. So when I think of IoT, when I think of these sensors, these systems that are talking and working together, is it more of a software update for those, or is it like is there outside software that you can buy and implement within those? How does all that work?
It really depends on how the company that created the device set it up. If they created a very specific device that, say, I don't know, checks the temperature, very simple. For that type of device, you're probably never going to see like a software update, or even, as kind of like what you're hinting at, sort of like a software replacement. Like maybe I want to load my own software on there. Something like that, it's probably going to be what I call like baked into the device. So that device is going to serve one purpose until, say, a hardware error occurs. And at that point, it's probably going to just be a paperweight in a way, and you basically have to throw it away.
So Ryder, what steps are companies taking to protect user data and information?
So it seems like every single company is kind of going their own way and seeing what works for them. And that's just because there's sort of standards in place, but they're sort of recommendations. So every company is thinking, we'll go this route and see if it works for us. And eventually it does until there's sort of information leaks. So as far as, what steps they're taking, it's all for their company specifically. And that could have other implications because really when we're talking about these devices, they could become corrupted or they could be hacked, right? So not leading companies, bigger companies, what they could do is they could try to have detection patterns in place to sort of see if faulty data is coming through or if devices are compromised in a way. If they have like those sort of preventative measures in place, that's something that they could be doing to sort of enhance security, not only for the data as a whole, but for consumers as well. Because at any point, a device could become compromised either physically or digitally. That's one step that they could be doing. Another step that they could do to sort of enhance security is sort of anonymize data and remove personal identifiable information. If you could do that, then these data leaks that we talk about all the time and that we hear of, those will be sort of not as impactful because if certain people's information is leaked, depending on what it is, and if it's anonymous and we know it doesn't belong to you, that's not the biggest deal. It is a problem, and then the company can react and figure out why it leaked, and then they can protect their own sort of services better. But as far as like if we're talking about sort of company-specific security and like their own IoT, the best thing that a company could do is sort of keep these devices on sort of like an internal network that's not exposed to the internet. Because once you expose yourself to the internet, that's when anybody can try to gain access somehow, some way. And if they can gain access to that device, it could eventually lead to access to your own sort of internal software. And once they have access to that, like they'll be able to access all of your client information, all of your internal customers. So really, from a consumer standpoint, with security, you sort of, as a consumer, have to ask yourself if you are comfortable with all the data that these devices are collecting, if you're comfortable with that data eventually leaking. And I think companies can be a little bit more sort of transparent on the data that they do collect and what they do with it. So if they collect like sort of things that you say to it, and if they're transparent and they say, well, we kind of use your audio clips in a way and kind of run them through machine learning to sort of offer you better services, they should be upfront about that.
Yeah. I think it would give a lot more protection or I guess peace of mind to the consumers using these different products if they knew exactly what the data was being used for. But everybody would just rather worry about making more money off of your data than actually explaining to you why they're using it and how it's beneficial to you. A question I had on something you said earlier is not exposing your information or your contacts to the internet. Is there a certain size your company would reach where that's no longer possible?
I guess I don't know what you're asking there.
So you said to house all your information internally pretty much, and then it doesn't expose it to the internet. So then it's much harder for them to get in to steal that information from you. I guess at what size would your company be? Like, can a Best Buy do that? Or are they so large this information just has to be on the internet because they can't house that internally? The server sizes would take up far too much room. Or, I guess in our industry, are there any companies that would be too large to be able to do this to protect client information and vendor information?
I think it all depends on, how much information that you actually gather and how many sort of like, say, devices are transmitting data and how much you actually want to keep around. So I would say at the start, of any of sort of these projects, the more data, the better. But you may run into, well, now we have too much, and now we have to, say, store this data in the cloud. And we may find that storing it, say, internally and then putting it in the cloud becomes too cumbersome. Let's upload it directly to the cloud. And there could be other sort of security implications there where maybe you're not thinking enough to secure all of those sort of like uploads of that data. So I would say it just depends on how much data you gather and how much is meaningful.
Okay. Derek, did you have anything else on security you wanted to touch on? I think we've gone on for quite some time here now and covered quite a few different things, and we'll do a quick wrap up at the end there, but anything else that you feel is pertinent we didn't mention?
No, I think we hit everything that I was thinking of.
Ryder, anything on your end?
I don't think so.
Okay. Well, then we will wrap this up here. And Ryder, we thank you for your time and thanks for coming on the show. We appreciate it.
Thanks for having me.
Of course. So as always, we're also going to remind you really quick that if you enjoyed the show, please remember to like and subscribe here on YouTube if that's where you are getting your content. But if you are getting your content from any of the many podcast channels where we can be found, please remember to subscribe. And if there are any questions or if you would like to hear us discuss any topics, as always, leave it in the comment section below, and we'll see you next time.